Finding a rock in space is interesting, but up to a point. Finding a planet full of things that are crawling or speaking a language you don't understand is a heck of a lot more interesting.
For millennia, mankind has searched the heavens for signs of life, to answer one of the greatest fundamental questions regarding human existence: are we alone? Finally, mankind's endeavors to seek the greater truth have come to fruition, as we now have the capability to explore the vast expanse known as the universe.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, engine start, 1, 0, and liftoff of the Delta II rocket with Kepler on a search for planets in some way like our own.
Kepler's mission is to locate planets orbiting stars outside our solar system. Kepler will stare at roughly 100,000 stars and monitor their brightness over the lifetime of the entire mission, roughly 3.5 years.
The results from Kepler will come from measuring the brightness of the stars. The data will look like an EKG showing heartbeats. Whenever a planet passes in front of its parenting star, viewed from our solar system, it will produce a tiny beat. From the repeating beats, we can confirm the existence of Earth-sized planets and learn about the orbit and size of the planet.
The idea of observing the slight reduction in the light of the star when a planet orbiting around that star passes in front of the star, that so-called transit method, is one very successful technique for inferring the existence of the planet without seeing the planet directly.
The Kepler mission will be looking at over 100,000 stars in the Cygnus and Lyra constellations. The field of view is extremely large for an astronomical telescope. Most telescopes, such as Hubble Space Telescope, only view a very small region of space, about the size of a grain of sand held at arm's length. Kepler covers a much larger field of view, about the size of your hand held at arm's length. The types of planets the scientists working on the Kepler mission are particularly interested in are planets located inside the habitable zone. This zone is often referred to as the Goldilocks zone. Who better to explain the Goldilocks zone than Goldilocks herself? Recently we caught up with the infamous vandalizer of bears' houses.
Can we get a word with you?
Actually, it's Dr. Goldilocks.
Doctor?
Let me guess, you want to ask me some questions about the breaking the furniture and eating all the porridge?
Well, yeah, that's what you're famous for. But
I've done other things with my life, you know. After all that, I went on to graduate from the University of Arizona with a degree in astrophysics. Anyway, what did you want?
Astrophysics. Speaking of astrophysics, would you mind explaining the Goldilocks zone? You know, the one named after you.
Sure. It's really simple. Here's your star, and here's your planet. If the planet is too close to the star, then it's going to be much too hot. If the planet is way far away from the star, then it's going to be much too cold. And if it's in the middle, then it's going to be just right, like the porridge.
To add to that, stars that are smaller, cooler, and lower mass than the Sun have their habitable zones much closer to the star. Stars that are larger, hotter, and more massive than the Sun have their habitable zones much farther out from the star.
If the surface of a planet has this range of temperature, it means water can be at the liquid state, in which case life as we know it can probably develop. And that's the Goldilocks zone, a place in which the average surface temperature of a planet at a certain distance from their own star allows the temperature of the surface to be that of liquid water.
So what kind of luck is Kepler having? To date, the Kepler mission has confirmed 61 planets with more than 2,000 others as good candidates. Here are some of the Kepler mission's most interesting finds so far. Kepler 10b is a blazing hot planet orbiting its star at 20 times closer than Mercury orbits our own sun. This planet's surface temperature is thought to be more than 2,500 degrees Fahrenheit. That's hotter than lava flows on Earth. Luke Skywalker would feel right at home on Kepler 16b. Actually, this planet is thought to be too cold and gaseous to support life, but like Tatooine from Star Wars, it orbits two stars. But perhaps Kepler's most interesting find so far is Kepler 22b. This is the first planet that Kepler has confirmed to be in a star's habitable zone. Kepler 22b is about 2.4 times the size of the Earth. It is also the most similar to our own planet.
So we now know, for the first time in human history, in your lifetime, we now know in the last few years that most and perhaps even all of the stars that you see in the nighttime sky and of the stars in our galaxy and probably other galaxies, most if not all of these stars do have one or more planets. That's a fascinating piece of information that is only very recently known to the human race.
How big is our galaxy? Imagine if each star in our universe were like a grain of sand. There are about 1 million grains of sand in this cup. Scientists believe there are about 200 billion stars in our galaxy. We would need to fill 200,000 cups with 1 million grains of sand each to reach 200 billion. And that's just the number of stars in our galaxy. Scientists believe there could be as many as 1 septillion stars in the observable universe. That's a 1 in 24 zeros. Referring back to our sand here, that's more grains of sand than all the beaches and deserts in the entire world.
Given the vastness of the universe, the potential amount of planets is unimaginable. The sheer volume of stars alone in our galaxy would seem to give us a great chance to find life.
If you find it here only, you can say, okay, this is unique. If you find it here and there, just this fact changes completely everything, because if you find it in one place only, you can say, okay, this is a very rare event. If you find it in two places, you can immediately say, oh, it's very common.
So why do we use the transit method instead of physically going to these stars? Why don't we just fly out to these planets and get a closer look?
Why is it not possible to go to this star system and see the planets? Well, really the answer to that question can be, in some sense, stated in one word: distance. The stars in the nighttime sky are very far away. An analogy that I use when I teach astronomy here at the University of Kentucky is this. I say, imagine that the sun is the size of a ping pong ball. We reduce everything in the universe. So the sun now, typical star, is the size of a ping pong ball. Now on that scale, the most distant planet in our solar system would be 500 feet away. So a little bit across campus, about a block away. On the same scale, with the sun the size of a ping pong ball, you can ask yourself, how far away is the nearest ping pong ball? The nearest neighbor star to the sun, the nearest star of the nighttime sky. And the answer is, with the sun the size of a ping pong ball, and Neptune 500 feet away, the most distant planet in our solar system. The next ping pong ball, Alpha Centauri, or Proxima Centauri, whichever you prefer, the sun's nearest neighbor star, would be 700 miles away. And that's just the nearest star of the nighttime sky.
We may never find out if we're alone in the universe, but thanks to Kepler and other missions like it, the search will continue.
Okay, Chris, you gotta make sure there's 1 million little pieces of sand in this cup.
What? Why do I have to do this?
Because this is what you're gonna do for the project.
Two. Three. Alright. 51,296. 51,296. And 999,968. 9,969.
You're still not done counting that?
No, you count a million. Like,
It's been like 10 hours.
it's almost there. Almost there.
What number are you on?